We got inequalities here. So let's talk about inequalities. Jalen said that it's something that is not equal. So instead of equal sign in your equations, what we're going to deal with is inequality symbols. Anybody know what those are? Inequality symbols?
Isn't that like an equal sign with a line through it saying no equal?
Oh, yeah, technically not equal is one of them, but we don't use that in this class. What was that gesture? Yeah, you guys are
in the greater or less.
Thank you. Those are your inequalities. But here's a condition. Ready? Listen. When you're reading the inequality symbols, you always read it from the variable side. So x is to the left, and if x is to the left, you read it as x is greater than whatever the number is, right? Okay, so I'm going to put a number symbol here. So this, when x is over here, this symbol, the open mouth side, is greater than. So this is a greater than symbol.
So the variable is always greater than the number?
No, not necessarily, but you read it from the variable side. So next one. So this is a greater than, right? X is greater than whatever the number is. Or if I had an x here, now this time the symbol is pointing the other way with the pointy end. Remember, open mouth is the greater than side, pointy end is the less than side. So now the pointy end is toward the x, and when you read it, when you read the symbol, you read it as less than.
It'll eat the bigger number. It'll eat the bigger thing,
Okay.
and then eventually the second one will be the bigger thing.
Okay. All right. So now on the other side of this, though, if I have x's, now what if there is a line under it? Or equal to. So greater than or equal to. Okay. So this says x is greater than or equal to a number. So this is greater than or equal to. Okay, greater than or equal to. Okay. And then here's the x again, but the pointy end this time is pointing toward the x. So you read it as less than or equal to. So that will be less than or equal to. And these four symbols are called inequalities. These are your inequalities. So there are many, many solutions, right? So solutions, somebody says solutions of the inequalities, right? Solutions means answers of an inequality. Solutions of an inequality is any number that makes the inequality true. Okay, so solution, which is the answers to an inequality, is any number that will make inequalities true. That will be the solution. So when I give you an example, I'm going to call this example, let's just call it an example. Ready? If I said find solution of, ready? X is what does that statement say right here? X is what?
X is greater or equal to 5.
Okay, so how many solutions are there in this particular statement?
5 or more.
2. Okay, anybody else?
There's a lot, like.
Yeah, there's a lot.
It could be any number other than 4, 3, 2, or 1.
Anything that's below 5, right?
Oh, infinity.
Yeah, you have an infinite amount of solutions.
So
right? So like when we did a warm-up, when it was an equal sign, you had one answer, right? But inequalities, you have so many, right? Because it's anything greater than or equal to 5, the best way to represent this solution is to graph it, okay? So on a number line, when I graph this, on a number line, because number line represents all numbers, right? And it goes on forever this way, it goes on forever this way because of the arrow. To represent the solution of this, the best way to show the answer to this inequality is to graph it. So I'm going to put a 5 here, because I could start the number line anywhere. Or C, just focus on that area where the number is, right? So here's 5, I'm going to pick a number before it, which is 4, and number after, right? Because number line 4, 5, 6, it goes in order, least to greatest, right? So now, to represent all numbers that are solution to that inequality means that I'm going to graph it and show where all those numbers are located. Well, because of this line, it's going to include 5, right? X could be 5, right? Because it says or equal to. So what I'm going to do is I'm going to put a little circle with a closed circle to include 5. And then which side of the 5 is greater than 5?
Right?
To the right. Okay. So all numbers to the right side, because that's the 6 side, right? 6 is greater than 4. This is where my solutions are. All the numbers that will go on forever, right? Including 5, I have 5.5, 5.75, 5.96, 6.1. Those are all greater and forever. So this is how you represent the solution to that inequality. Does that make sense? Okay. All right. So because solution is any number that makes the statement true, so if I gave you this, I'm going to ask you, an example number 2. Is each
So this is what we're doing.
number a solution of 3 plus 2x is greater than 8. So here's my statement right here. That's my inequality. Now, is each. So here's A. I'm going to tell you, here's my A. Is A, which is -2, is this a solution? Is -2 one of the x values that will make this statement true? How would you do it? Solve it or take this number and plug it in. All right? So we're going to do 3 plus 2 times -2. Is this side, that's what you're checking for, is this side going to be less than 8 after you plug it in? Well, let's see. Remember, using the order of operation, 2 times -4, I mean -2 is 3 plus -4. Is this going to be less than 8?
Yeah.
Well, 3 plus -4 is -1. Yes, -1 is less than 8. So yes, -2 is a solution. That's what you're going to be doing
Wait,
today.
it is?
Yes. Isn't -1 less than 8? So, -2 is a solution, is one of the answers to that inequality. Okay? Now you tell me, if I gave you another one, is 3 a solution to that inequality? Well, let's check again. Let's plug in 3. Right? I'm going to plug it in.
Actually, yeah, it would be,
No, it
because
would-
3 plus 6 is,
9.
There you go.
it would,
So
that's
3
greater.
plus 2 times 3. Now we're going to plug 3 in, and then we're going to check to see if that's going to be less than 8. Well, 2 times 3 is 6 plus 3. Is that less than 8? Well, 3 plus 6 is 9, and is 9 less than 8? No. So guess what? 3 is not a solution. That's how you check, by plugging it in. Is there another way to check? Anybody know? Whether it is or not? Well, we'll save that for tomorrow. Any questions so far?
No.
No? Okay. Well, our second goal was to graph and to write inequalities, right? So I'm going to give you a little table here. Okay? I'm gonna make this a key. This is your key for today. remember, the x's are, you always read the x from the variable side, right? So if I put the x, I got this symbol, right? It's greater than. I'm going to also do x is greater than or equal to. And then I got x is less than, the pointy end is the less than side. And x is less than or equal to. So there's the pointy end. So we're making a key. And we did this in our support class. All right, so if x is on the left and if it's greater than or less than, I'm going to draw a circle around those two. If you have greater than or less than, it's going to, because it's greater than or less than, not or equal to, this is going to be an open circle. On the number line, see right here when we did this? On a number line, at that 5, we did a closed circle. But if you see one of these, you're going to put an open circle. Open circle. Okay? But if you have greater than or equal to or less than or equal to, if you go this way, this is going to be a closed circle on the number that is greater than or equal to or less than or equal to. So this is a closed circle. Cool? Okay? And then we're going to read it this way now. If you read it this way, if it's greater than or equal to, because it's the greater than side, and remember, right side is always greater than the left, we're going to shade to the right. Shade to the right. So we're going to be going like this, shading to the right. And remember, the variable is on the left. So when the variable is on the left, if you see less than or equal to, this one, because less than is the left side, we're going to shade to the left. So we're going to be shading this way. Okay? That's how you're going to graph it. And if I give you a graph, you should be able to write an inequality also. But this is a key that you're going to use today. Okay? This is our key. So let me give you a couple examples, and then we'll be done with the lesson. Okay? All right. Here we go. Ready? Or are you done with the key? Is everybody done with the key? You still writing? Okay. Is this helpful, the key? It will be? Okay. All right. So here's example number 3. It says graph. Anybody want to read what this says? What does it say? Jalen, go ahead.
Graph x is less than 3.
Thank you. So open or closed?
Open.
Open. And right or left? Left. So if you notice, this is going to be open and to the left. That's what you see, right? That's what I see. So now when we graph it on a number line, you locate the 3, put a number before and after. On 3, it's an open circle because it does not equal to 3. And we just shade to the left. Any questions? So all the numbers to the left of 3, even 2.99999, is less than 3.
So
Okay.
when you have that key in the test, do we get?
No, you got to know it. Okay? All right? Let me give you another one. I'm going to call this A. Let's do B. Ready? Graph. Oh.
So -2 is greater than x.
Or, remember I said read it from the variable side.
Less than -2.
X is less than, because the pointy end is less than,
-2.
-2. So is it open circle, closed circle?
Open.
Open circle. And which side do I shade, right or left? Left, because it's less than. Okay? So, on a number line, locate -2. Here is -3. Here's -1. Everybody understand that more negative, the smaller the value, right? And then we said it was a open circle. And because we're reading it from the variable side, it is less than, so we are going to the left. Okay? So always read it from the variable side. Any questions so far? All right, so if I give you an inequality, would you be able to write an inequality? If I gave you a graph?
Yeah.
Yeah? So if I gave you, I'm going to say write an inequality. Inequality, sorry. I'll put equality. So if I gave you a number line with numbers -1, 0, 1, 2, 3, 4. Let's do right. Anybody want to try what this inequality says? Jonathan?
X is greater than
Good. So here's all these numbers over here are your x's. And it's greater than on the right-hand side of the 1. So x is greater than, not or equal to, because it's an open circle, so it's not going to equal 1. But it is to the right, so greater than 1. And that is the inequality for that graph. Now, what would it be if I had a closed circle?
X is greater than or equal to.
Okay. Any questions so far on how to do this? Okay, last example. You ready? No?
Yeah.
Yeah? I mean, is everybody done writing? Yes? All right, last one. You ready? It's a word problem. Well, kind of. It's just a lot of words. All right, this is example number 5. It says, define a variable. As you know, when we do word problems or story problems, you always define. It says define a variable and write an inequality. For the given situation. All right, so here's one. Ready? The speed that violates. What does that mean, violates?
It goes
Against the law, right?
Yeah.
Violates the law, right? When the speed limit is 55 miles per hour. So I want you to write an inequality that would represent this situation. So I want the speed that violates the law when the speed limit is 55 miles per hour. So the very first thing we must do is to define a variable. Okay? Delaney, what letter do you want to use for what in this situation? S? Or did you say X? Okay, so we're going to, and what we're going to let X represent? Speed. That violates the law, right? Okay? Anybody want to write the inequality for me? If X represents the speed that violates the law and the speed limit is 55 miles per hour, what will violate? Yes, Natalie. X is greater than 55. So anything greater than 55 would violate, right?
So open circle goes away.
Open circle, thank you. So when we graph it, here's 55, here's 50, here's 60. Open circle, anything above 55, you will get a ticket if you get caught. Make sense? So did you see how we defined this variable, what x stood for? It represents all numbers that would violate the law if the speed limit is 55. Any questions with that so far? So let me give you some keywords. This is going to be helpful, I think. Sorry, it's a lot of notes, huh? All right, ready? The word at least means minimum. At least. So the inequality you're going to use for this is greater than or equal to. At least. Greater than or equal to. At most. That's a maximum. So what do you think what symbol do you think we're going to use for that one?
Opposite, so.
Yeah, opposite of this, right? So if it's greater than or equal to, what's the opposite? Less than or equal to. Right? How about more than? What would that be?
X greater.
Greater than. Yep, x is greater than. Let me see other words here.
Less than.
Sure. Less than. X is less than. I'm trying to see some. Ooh, how about no more than? What would that be? No more than. Yes, ma'am. Say it again. Equal to or less than, right? So it's less than or equal to, right? No more means less or equal. No less than. What would that be? Opposite of this one. So if it's no more than, it's less than or equal to. No less than will be greater than or equal to. I think those are the main things. If we have more, I think we can add to it, okay? Any questions about today? Should be fairly easy. You guys agree?